Well, dear students, here I come with Bohr model of atom. Actually, Rutherford gave nuclear model of atom. He told that total positive charge and mass of the atom is concentrated in the nucleus. Electrons are outside, but he was unable to explain why electrons are outside the nucleus, because according to electromagnetic theory, the moving charge particle radiates energy continuously. So that model failed to explain how the electron remain outside and why the spectrum of light produced by hydrogen atom is line spectrum, not continuous. If electron loses energy continuously, then a spectrum of every element should be continuous. Then Neil Bohr studied the structure given by Rutherford atom. He studied the model of atom given by Rutherford, and he restricted the theory of electromagnetic waves. He told, okay, it is correct for some region, for some place, but we cannot apply electromagnetic theory of electromagnetic waves in case of atoms. And Bohr used classical mechanics and quantum mechanics together to explain the model of atom. Here, Bohr told that theory of electromagnetic wave. What is that? Accelerating charge particle lose energy in the form of electromagnetic wave is not true in case of atoms. So to explain, here in this video I will be telling you only assumptions of Bohr theory, and in coming video I will derive expression for radius of an electron orbit, velocity of electron in any orbit, energy of orbit, and other things. But in this video I am taking only assumptions. So Bohr explained the model of atoms I should say, using classical mechanics and quantum mechanics together. Quantum mechanics. You may think that what is classical mechanics? I told you mechanics branch of science in which we study objects that or in motion. Classical mechanics means that physics in which Newton's law of motion hold true. Quantum mechanics in which Planck's quantum theory is followed or hold good. So Bohr explained the model of atoms using classical mechanics and quantum simultaneously. with the help of following postulates. Following postulates और assumption भी कह सकते हैं जगह assumption. Bohr admitted the nuclear model of the given by the Bohr. So first assumption is that जो गड़बड़ करते भाई Bohr agreed that total positive charge and mass of atom is concentrated in the nucleus. Ze charge, Z is atom of atom, it is the nucleus. Electron revolved. Here, suppose this is nth orbit and this is velocity here. ना भाई तो फर्स्ट पोस्टुलेट क्या है भाई फर्स्ट पोस्टुलेट total positive charge and mass of atom is concentrated in the nucleus of atom. Electrons revolve around the nucleus. In different circular orbits. एक्चुअली सोलर सिस्टम मॉडल लिया हमने द centripetal force required by an electron is provided by Coulomb's force of attraction between charge of electron and charge of nucleus. Actually, charge electron negative and nucleus positive, and therefore here I can write if an electron revolve around the nucleus of about the nucleus in circular orbit. In nth circular orbit. nth means पांचवा चौथा जो भी होगा orbit with of radius Rn with velocity Vn, then we can write, I am drawing it here, this is nucleus Z charge, radius Rn, velocity Vn. So central force mvn square upon Rn is equal to 1 upon 4 pi epsilon 0 Jd square upon Rn square. Jd charge of nucleus or charge of electron. So Jd square. Mass m is the mass of electron. You know this 4 pi epsilon 0 etc. This is first assumption. This is first assumption. Dear student, learn like it. So electron revolve around the nucleus in circular orbits, and when a body moves circular path, that needs centrifugal force. That centrifugal force is provided by force of attraction between charge of nucleus and charge of electron. I hope you will be enjoying my teaching of this topic. Actually, it is very simple, but थोड़ा सा concentration चाहिएगा. Now, what is second postulate? Please remember this equation one. M is the mass of electron here. Second postulate, interesting one. Dear student, Bohr told that electron revolve in circular orbits. Now, which circular orbit will be chosen by electron to move? There may be many circular orbits. So here, this equation totally related with classical mechanics. F is equal to ma. F is equal to ma तो है न्यूटन सेकंड ला और a बराबर है v स्क्वायर बाई r. तो दिस इज न्यूटन फर्स्ट ला. In second postulate, Bohr used quantum mechanics as well as classical together. एक साथ कैसे? An electron can revolve. Electron can revolve in that one orbit in which its angular momentum is an integral multiple of h upon 2 pi, whereas Planck constant, you know, that is mvnrn. mvnrn is equal to nh upon 2 pi, where equation 2, where n is equal to 1, 2, 3, 4 and so on. And later on this n became principal quantum number. Principal quantum number. So first equation mvn square upon Rn is equal to 1 upon 4 pi epsilon 0 Z square upon Rn square. Or second mvn is equal to nh upon 2 pi. The second position. Angular momentum, actually linear momentum, P equal to mv. When body moves circular path, the product of linear momentum and per distance from acceleration is equal to the magnitude of angular momentum. So here it applies the classical mechanics as well as quantum mechanics. nh upon 2 pi, angular momentum. You may be asked what is the angular momentum of an orbit in first orbit. So n equal to h upon 2 pi only. H Planck constant, unit of angular momentum joule second, and h has joule second. Now third postulate. So now Bohr puts the restriction on theory of electrodynamics. वो क्या किया उन्होंने? When an electron revolves in any orbit, though its motion is accelerated. When an electron revolves in any orbit, it neither loses nor gains energy. Nor gains energy. Therefore, an orbit is a stationary energy state. What does it mean energy state? कि इलेक्ट्रॉन यहाँ से अगर दूसरा ऑर्बिट है तो दूसरी स्टेट या फर्स्ट स्टेट and their value of energy in any orbit does not change, neither degree nor increases. That is why it is called energy stationary, means does not change. Body at rest said to be stationary. So here stationary means energy does not change. The electron loses, the losses क्यों नहीं है, loses energy or gains energy when it jumps from higher orbit. I want to say from higher energy state, but still I am using orbit so that you understand. From higher orbit to lower orbit. lower orbit, and vice versa. Vice versa means if jump goes from lower to higher, it takes energy. When electron goes from lower to higher energy state or orbit, it takes energy. So, if an electron jumps from, so if electron jumps from N2 to N1 orbit, then energy emitted or lost in the form of electromagnetic waves is given by En2 मतलब energy in N2 orbit minus En1 energy in N1 orbit is equal to H upon is equal to H nu, where H Planck constant and nu is the frequency of radiation emitted by electron while going from higher to lower. It will take the same energy to go up. So these are assumptions of conservative gases. On the basis of this, we will try to explain the spectrum of hydrogen atom. When hydrogen gas taken in a bulb and the gas is excited by passing electric current, it emits radiation of different wavelength. So we will explain them in next video. With the help of these postulates. If you like my video, please like the videos, subscribe the video, ask to your friend, and you also, if you have not subscribed, please subscribe my video, and ask your friend also, whosoever is appearing class 12 exam or appearing any competitive exam, everywhere it will help you. Thank you.